A compound inequality is anything where you have two pieces separated by either an and or an or. So there's only two possibilities when we talk about compound inequalities. So there's like two conditions that you can graph at once on a number line. So with these two cases, I want to see what the answers look like for we have negative 4 is less than x, and at the same time, x is less than 5. Anytime you see and, it means you're trapped between the two values, in this case negative 4 and positive 5. I'm going to put an open circle at both, so let's say this is negative 4, this is positive 5, an open circle because there's no equal sign on either of the inequalities. To say that x is greater than negative 4 means we're moving in this direction, and at the same time x less than 5 means we're going in this direction from 5. The overlap where that happens is from negative 4 to positive 5. And so our answer looks like this. So if we see an and symbol, we're really trapped between two values. So we get nothing over here and nothing over here. Furthermore, in this case, when we're dealing with just an and compound inequality, we can condense this into one concise statement. Negative 4 is less than x is less than 5. So it's often customary to, instead of write this, put it into just one statement that appears here. Now let's compare this to or. So let's say we have x is less than negative 2 or x is greater than 1. So again, we're focusing on two numbers, negative 2 versus positive 1. I'll put an open circle at both of those places. And to say or means either can happen. I'm not looking for any overlap. If I start with this first one, less than negative 2 means I'm going in this direction. And if I said or x is greater than 1, I start here and go in this direction. So here is x is less than 2, or x is greater than 1. If you put the word and in between these two inequalities, the answer would be nothing. You cannot at the same time be less than negative 2 and greater than positive 1. So when you see or, you are allowed to have these two separate pieces. One other final thought on the or inequality, we don't write it into one statement like we do an and statement. It's customary just to leave it in this form here. Anytime that we have one statement, we're saying that these conditions happen at the same time, and that means and. So whenever we see or, we leave it just like this. So let's solve the inequality, the compound inequality that appears in example 1. So here I have negative 3 is less than or equal to 2x plus 1, which is less than 6. So this means and, since I put it in one statement. If you wanted to, you could break this up into two pieces and say, I know what this means. It's asking where is 2x plus 1 greater than negative 3, and at the same time, where's 2x plus 1 less than 6? So it would be completely okay to do this. However, I'm going to leave it in this form and solve for x by working on both sides of my inequality. So here's what I mean. If my goal is to get x by itself, so get rid of this 1 and get rid of that 2, I need to first subtract this 1. So that means I'm subtracting 1 from the 6. But at the same time, we can also just subtract the 1 from the negative 3 and just do it in one line. It would look like this. If I subtract 1 from this inequality and this inequality, my result would be negative 4 is less than or equal to 2x is less than 5. The only other step now is to get rid of this 2 by dividing it, but here I can divide that to both sides of this inequality at the same time. So that is, if I divide this by 2, why not just do both of those numbers at the same time? My result is negative 2 is less than or equal to x, which is less than 5 halves. I think I'll use a decimal and just put 2.5. So an and inequality is nice because you can work through it like this, where I'll subtract my negative 1, but just do it across the board. Same thing for division by 2. Just divide it to every single side of the inequality. I know what this answer means. it means that I can draw a number line, so I'll just kind of sketch that on here. Here's my number line. I'll write -2, and over here I'll put positive 2.5. I'm going to put a closed circle at -2 because there's an equal sign on that portion of the inequality, and an open circle at 2.5, and I'm going to take everything in between. These are all of the numbers that make this original inequality true. So like I said, you could break it apart into these two pieces and then solve each independently. So I'm just going to do that. I'm going to put the work down for it to see how it compares to the answer that we have over here. So there's the work for this process. I subtracted 1 and then divided by 2. I just did it in two separate pieces. But the answer we get is exactly the same thing as the process we did over here. So it's for this reason that with an AND inequality, I would suggest going through the work this way. It just is neater and quicker. But we do arrive at the same answer if you were to break it apart into two pieces. And for example 2, I wanted to now look at an OR inequality. And this one's going to be just a little bit different because the parts that have the variable, the x in it, in this time are not the same. That is something that can happen, there's no problem there. But my goal is to solve for x in both of these pieces, but it's just customary to do it separately if you have an OR statement. So the idea is the same, where I'll take the first one, and I think this is going to be really quick, right? I just subtract 1 from both sides and I get x is less than -5, no problem there. And then OR, all right, this next one's going to be a two-step process, but I'm first going to add 9 to both sides, which gives me 3x is greater than 6. So I have to go another step here where I'm going to divide both sides by 3. Now when I do that, I'm going to copy this whole line down again, even though I'm not doing anything to this piece here. So that is, I still have x is less than -5, or x is greater than 2. All right, so I'm now set to write my answer on a number line. Draw it like this. I'll mark both -5 and +2. So I guess, here's -5, over here is +2. An open circle at both, just because there are no equal signs on my inequality. I'm going less than -5 or greater than 2. So this would be the answer to this inequality. Again, we leave it in two separate pieces when we're dealing with an OR statement. I did want to focus on one last thing here for this problem, which is, why don't we then just group this back into one statement without using the word OR? I kind of hinted at it earlier, but let's see what happens if we try to do that, where I take this and just try to write it into one expression. So x is by itself. So I guess to start with, well, x is less than -5. So if I'm doing this in the proper order, it would look like this, right? X is less than -5. And then we have this piece over here where, okay, 2 is less than x, or x is greater than 2, so you'd have to incorporate it like this. And this is why we don't write it in one statement, because things become confusing. We've already said that this means and. We've defined the and statement to mean this type of form. So this is saying x is greater than 2 and at the same time less than -5. And the problem is, there is no number that is positive and then at the same time negative. So this is the reason for not combining it into one statement. We define this to mean and in this case, there could be some confusion where, wait, there's no number for which this is true, like nothing works. There is no number which is both positive, greater than 2, and negative, less than -5 at the same time. So we say like, okay, this is no good. We're not going to combine it into one statement. We're just going to leave our answer over here in two separate pieces to avoid confusion.